This presentation introduces the new design standard CS229, Data for Pavement Maintenance. Part of the new design manual for roads and bridges, it is contained within the Pavement Inspection and Assessment section. The presentation relates to the main document and the English National Application Annex. The presentation will cover where CS229 has come from and its relationship with other new pavement documents. It will review the main changes and it will describe CS229's place in pavement renewals. It will cover the data for pavement assessment and explore the changes in more detail, and will conclude with a brief summary. The design manual for roads and bridges has been refreshed and new standards have been created to support asset management life cycle stages. The old HD29 has been split into scheme level and network level surveys. CS229 Data for Pavement Assessment defines how to undertake detailed surveys. These will support technically complex maintenance. CS230 Pavement Maintenance Assessment Procedure covers the network level surveys, which will help support technically simple maintenance. It's important to note that CD227, Design for Pavement Maintenance, draws the processes together and introduces the requirement for an investigation plan. The new CS229 standard contains a lot of detailed changes, improving technical standards and providing safer practices. Visual condition surveys are to be done using forward-facing and downward-facing images collected from traffic speed surveys using TRAX4. Safety improvements are again provided for deflectograph and FWD surveys by removing the need for drilling holes in the carriageway to measure temperature. This reduces the exposure of road workers. Better quality control of data is provided by setting out temperature ranges for use in FWD and new requirements for testing of jointed pavements. The latest advances are included in the requirements for ground penetrating radar, and this provides upgraded guidance on its application and provides confidence ranges for the different applications. Clearer guidance and recommendations for reinstatements are provided for invasive testing in cause and trial holes. The diagram shows the relationship of CS229 Data for Pavement Assessment with the other pavement standards. CD227 Design for Pavement Maintenance establishes a requirement for an investigation plan, informed by the visual condition survey described in CS229. The plan then informs which other surveys should be carried out as described in CS229. CS229 Data for Pavement Assessment supersedes the previous HD29 and covers the requirements for undertaking detailed scheme level pavement investigations. The standard sets out how the survey shall be undertaken, what the limitations are, and the permitted use of the data. It covers three of the main survey requirements: visual condition surveys, deflectograph structural condition surveys, and coring and dynamic cone penetrometer invasive testing. It also covers the optional tests where needed for falling weight deflectometer structural tests and ground penetrating radar investigation. The English National Application Annex for CS229 introduces the requirement for visual condition surveys to be undertaken using forward and downward-facing images collected at traffic speed. There are already images available from the Tracks 4 surveys. Other images of an equivalent standard may also be used. In describing the defects, flexible pavements and rigid pavements, there are differences contained within this standard. The defects assigned for flexible pavements are described in the Happens Visual Survey Manual, as opposed to rigid pavements where the definitions are contained within this standard. The deflectograph is the main method used to assess the structural condition of the pavement at the scheme level. The survey categories, the time of year, and the temperature limits remain unchanged from HD 2908. The main change is the introduction of the contactless method for pavement temperature assessment. This is recommended as it will speed up progress by removing the need to get out of the vehicle and drill holes in the carriageway. It reduces the exposure of road workers, and the deflectograph specific equation assesses the temperature at the 40mm depth. There is much more information about the deflectograph in Appendix A. The falling weight deflectometer is an optional method which can be used to give information on the structural condition of flexible and rigid pavements. There are a number of changes in the use of FWD in the new standard. Again, the option of contactless pavement temperature assessment has been introduced, and this is recommended as it removes the need to drill holes and measure the pavement temperature manually by a probe. In addition to speeding up the survey, it reduces the exposure of road workers to traffic. The FWD specific equation predicts the pavement temperature at the 100mm depth. To improve the reliability of FWD data, the spacing of the geophones has been standardized for both flexible and rigid pavements. These are shown in the table. The standardization removes the risk of error and confusion. FWD can be used to assess both load transfer efficiency and void intercept in jointed rigid pavements. Where these are both undertaken, they should be done simultaneously, and the load levels for void intercept should be used in the load transfer efficiency testing. To ensure the quality of the data gathered in falling weight deflectometer surveys on flexible pavements, a series of temperature ranges have been introduced. There are different ranges for flexible pavements with asphalt base to those with hydraulically bound material base. The unadjusted temperature of the pavement at 100mm is used to determine the category of the survey. To make optimum use of the falling weight deflectometer data in layer stiffness evaluation, a series of 3 categories has been introduced. These define the level of confidence to be given to the data. The table shown sets out the permitted use of the data in each category. Data in Category 1 provides the highest level of confidence and can be used in the design of renewal treatments. In Level 2, the data can be used to give a relative assessment of condition within a site. The use of data in Level 3 is not recommended. Further information on FWD is contained within the standard in Appendix B. Ground penetrating radar is an optional non-destructive test which can be used to obtain more information about the construction of the pavement and its internal features. GPR surveys shall not be undertaken when standing water or salt are present on the surface of the pavement. To make the best use of GPR, 4 categories have been introduced to ensure the accuracy and reliability of the data. There are 4 categories for commissioning ground-penetrating radar surveys to ensure the accuracy and reliability of the data. Data in Category A surveys can be used regularly in pavement assessment. Data in Category B surveys is suitable for confirmation of evidence gained from other survey techniques. It is recommended that surveys should only be commissioned in Category A and B. Surveys in Category C should only be used with caution, as a guide, and used with other data. Surveys in Category D are unproven techniques not yet demonstrating as suitable for pavement investigation. The table shows the category of different uses of ground-penetrating radar surveys. The performance of each technique at slow or traffic speed can differ, and the relevant category should be used for the chosen speed of investigation. Slower speed can improve the level of confidence in the data. Items marked with an asterisk are where the use of 3-dimensional GPR techniques will improve the quality of the data or improve the productivity and/or coverage. However, the use of 3D GPR does not change the category of the survey. More information on the use of GPR can be found within the Appendix C of CS229 standard. Invasive testing includes coring, the dynamic cone penetrometer test, and test pits. To improve the clarity and usefulness of the data, the new standard has enhanced the requirements for referencing. It is now a requirement to carry out GPS location referencing for each test using a GPS device with an accuracy of better than 1 meter. For cores, there are new requirements. These include a clear description of why the core was taken. Good quality colour photographs are required of the pavement surface before the core is taken, down the core hole showing the bottom of the core with a measurement shown by a ruler showing its full depth, and of the core itself after extraction. Photographs should also be taken of the reinstated core hole. A good quality colour photograph is one in focus, evenly lit, and shot with a high resolution camera, so that the aggregate and defects are clearly seen. There are requirements to determine layer thickness where the core has disintegrated during extraction, and report where layers or the full core has disintegrated. There are also improved requirements for test pits, including the reason why the pit has been taken, the traffic direction, the pavement layers, the condition of the material, and where the in situ tests are being completed. These shall be included on the test pit log. In summary, CS229 has replaced HD 2908, and this presentation covers the main changes. CS229 describes the technical requirements for undertaking detailed scheme-level pavement investigations. CS229 does not cover network-level surveys which are described in CS230, Pavement Maintenance Assessment Procedure. CS229 defines the limitations and permitted uses of the data. CS229 contains technical improvements and sets out methods to reduce risks to road workers, for example, temperature assessment. CS229 is complemented by CD227, Design for Pavement Maintenance, which sets out the requirements for determining the need for maintenance and designing maintenance treatments.